Now let's look at another idea where we can use the power of a proportion. So let's say, for example, that I was out with my buddy Walt and we were out tagging and releasing deer. And so we tagged 135 deer and released one day. A week later, we come back again and we're just out observing what we can see. And we went out and observed 140 deer. And out of those 140 deer, we observed that there was 30 of them that were tagged. Now this is a powerful use of proportions. So the obvious question we're asking is well, how big is our local deer population based on the observations we have and assuming that the population is consistent with what we saw? So from here we can develop a proportion. And remember, a proportion was a relationship of one ratio to another ratio. It was some A to B is to C to D, or some this is to that to another this is to that. And we need to keep that in mind that as we look at this. So let's develop our thises and that's. Well, we have tagged and we have the total deer that we saw in one sample. Well, in the other sample, we tagged 135 deer. These are tagged. But we don't know how many were in the total population. So you can see what I have here. Population to tagged, local population to tagged. I have thises and that's. So let's go ahead and work that through. So population to total deer tagged, X to 135 equals, how many tagged do I have? 140 to 30 tagged. Total population to tagged to sample population and tagged. So from there, I'm able to develop a portion solving for X. In this particular case, I can multiply both sides by 135. $140 times 135 divided by 30. Solve that down for X. I got 630. So based on this sample, I can expect there to be 630 deer in my total population. Now, a bit of a note here. As you're working out this, you might come up with a slightly different proportion using the same types of an idea. So for example, maybe you did tagged to population. So your starting proportion was maybe 135 is to X, as 30 is to 140. That's a fine and correct way to start the problem because you're comparing this is to that, this is to that. Likewise, you can also compare that's to that equals this is to this is. Well, in this particular case, what does that mean? Well, maybe that I'm going to look at population. I'm going to have populations. Total population to sample population equals total deer tagged to sample deer tagged. There is another proportion that I was able to build, and it follows a consistent pattern. Now, all of these I've done, I could derive from one to the other by just go ahead and using some algebra to manipulate that. But I just want to leave you now with the idea that maybe you will come up with a different starting proportion than your friend will. And you both could be correct, as long as you follow a pattern where you're comparing like objects to like objects.